Okay, so today is the last kind of crash course. And this is one where it's like a whole unit in our book. This is one that after testing we will come back to because I want you to have a better understanding of this by the time you leave 6th grade. But it's too much that I can't teach you the whole unit in a couple days. So I'm going to give you as much as I can today and trying to give you kind of hitting the important pieces. And then after testing, I'll come back and hopefully you'll understand it a little bit better, okay? So we are going to kind of work through, the slideshow is on the piece of paper in front of you. We're going to kind of work through some of this. More on the back, we're just kind of discuss the front. Will you put it on my chair, please? Okay, so the first slide says a variable is a letter that stands for a number. Is that new news or old news? Old news. It usually represents a number that can vary or change, meaning in one problem x could be equal to 7, in one problem x could be equal to 9. It doesn't always represent the exact same number. That's why they call it a variable. An algebraic expression is a mathematical phrase that uses variables, numerals, and operation symbols. So see how under each slide you have a little bit of a margin? I'm going to write stuff on the slide because I don't have that margin. You guys can just write under the slide when you take notes, or if you have room on the slide, you can. I want you to tell me and write down the difference between an expression, and again, just write this underneath this slide, and an equation. Who can tell me the difference between an expression and an equation? Dane?
An expression is with variables and an equation is with numbers?
Nope, good guess. You said an expression is with variables and equation is with numbers. They can both have both of those things. Nolan?
Equation has an equal sign and the expression doesn't?
Yeah, so an equation has an equal sign. An expression has no equal sign. Okay, expression has no equal sign. An equation has an equal sign. Jack, you got something else?
An expression could be have a lot of answers, and an equation could have one.
Not necessarily. I'm going to give you the next one because I don't think you guys know this yet. An equation you can solve. You can solve an equation. So like x plus 2 equals 5. What does x have to be? 3. X equals 3. You just solved that equation. On an expression, you can't solve them. You can just simplify them. X is greater than 3 is actually considered an inequality because you could give lots of values for that. So we know what an equation looks like, so let's write that out. Let's write x plus 2 equals 5. That is called an algebraic equation, or you could call it a variable equation. They're kind of used interchangeably because it is an equation, which means it has an equal sign with algebra in it or variables. Algebra just means there's letters involved. That's what the word algebraic here means. Who thinks they can give me an example of an expression? Carter? Okay, so if it was a division problem, so 6 divided by 12 would work. Okay, I'm going to write it like this: 6 divided by 12, and draw an arrow 6 over 12. Technically, that is an expression because there's no equal sign. If we saw 6 over 12, though, we would just say, hey, that's a fraction. Who thinks they can give me a variable expression? I wasn't very specific. Sadie? X plus 3. X plus 3 is a variable expression. It's an expression that does not have an equal sign. I can't solve that. Why not? Bryce? Yeah, we don't have enough information. If I had equals 8, I could solve it. Or if they gave me a value for x, I could simplify it. So if they said x equals 2, If they told me x equals 2, what would that expression simplify to?
2 plus 3.
2 plus 3, which is?
5.
5. Okay? And that's what we're going to kind of get into, is simplifying these expressions. Okay, but first we had to understand the difference between an expression and an equation. Let's go to the next slide. And I don't love the words that go, oh wait, we're not there yet. So you use abbreviations when texting, such as TTYL, LOL, and BFF. We use variable expressions to abbreviate math too. Meaning if you have a math sentence, we shorten it with variable expressions, x plus 2, y times 7. Okay, we can shorten the words into expressions. Now, M represents the number of muffins, is what this says at the bottom. And how many muffins are there? 2. So it's saying 2 times muffins, which I don't like the expression that goes with that. What I want you to remember from this slide is, how did they rewrite M times 2? 2M. These are the exact same thing. That's like a 5th grade way to write that. This is the upper elementary, so like 6, 7, 8. That is the best way to write 2 times M. Why does that not look like it says 2 times M? Bryce? There's no multiplication sign. So remember, like on exponents, if there's an exponent of 1, do we see it? No. There's all kinds of invisible math. The older you get, the more you see. You're actually going to learn 2 new things today. So if you see a number directly next to a variable, there's always a multiplication sign between it. It's just you don't need it, so we just smash them together. So let's do, in the margin, I want you to write this, 5x. If you see 5x, Jude, do you have a question?
Well, couldn't it just represent like 2 muffins?
It could, but it doesn't. Yeah. What do you think 5x is telling me? What math problem is that, Jack? 5 times x. So I want you to write 5 times x. What if we have 2x plus 3? That's a different expression. What math problem is that showing me? Chase, what math problem do you think that's showing me? 2x plus 3. Haley? 2 times x plus 3. That's saying 2 times whatever x is plus 3. Again, we can't do anything with that unless they made it into an equation where we could solve it, or if they told us the value of x. If they said x equals 7, then we could substitute 7 in for x and do an order of operation problem to solve it. Okay. Who thinks they can give me an expression? So words, well here, I'll do this one. We're going to write an expression for this numerical expression, this algebraic expression. We're going to do words. I want you to write the number of muffins doubled. That would be an expression to represent the number of muffins doubled. Because did we know how many muffins we had to start with?
Yes. Wait,
No. Well, we're ignoring the other stuff up there. No, we didn't know how many muffins there were. We just know that however many there were, it doubled. What math would you do to double something? Times 2. What word could you use to multiply it by 3? Tripled. What about times 4? Quadrupled. Yep, we don't see that one too often. Okay, let's move on to the next one. Again, I'm trying to get you just to see what these look like and then put some words that go with it. And I don't love this slideshow, but it had a lot of what I wanted to show you in it, all in one place. So, C plus 10. Not many other ways you could write that. There's only one other way I could write C plus 10. Who thinks they know another way I could write it and it has the same value? Dane? 10C. Not 10, that's 10 times C. Stella?
C10.
That's C times 10. Sadie? 10 plus C. Really, you can just flip it around is the only other way you could potentially write that. Now, in an expression, if you have variables and numbers, which at the end of this slideshow, it tells us those are called constants. Remember that word from the other day, Jude? You said that thing you said a minute ago? It's just a number. A number is a constant. If you have letters and constants, variables and numbers, all in the same expression, you put the variables in the front in alphabetical order if there's more than one. So if you have X, Y, and Z, you'd put your X's, then your Y's, then your Z's. General rule. Okay? Who thinks they can give me a phrase, and C is representing coins? That could be C plus 10. Jack?
The number of coins. Something by 10.
Okay, what's a word that means plus?
Added.
It is added does work, but they wouldn't use that. Let's say the number of coins, you can probably write this one on the picture. The number of coins, it wouldn't be doubled because that would be times 2. Increased by 10. If we don't already know the number of coins, which we don't, it doesn't tell us how many coins we had to start with. We just say C plus 10 because the number of coins went up by 10. If they told us how many coins we started with, could we tell them how many coins we now have? Yes, but we don't know that. That's what you guys won't like, is that our final answers today will look something like that. It won't just be 1, it won't be like 7 or 10. It'll be like C plus 10. Okay, let's keep going. Again, I don't love the pictures and the stuff that goes with these. I'm just trying to get you to see different algebraic expressions. What do you think that one, what's a better way to write that algebraic expression? Haley? No. She said, I'm going to write 2 divided by C. I want you to draw a big circle and a line through it. No. But common wrong answer. Jack? C divided by 2. Now, we could write that C divided by 2. This is okay, but you will almost never see it like that in 6th grade. Dane, how will we probably see it?
C over 2?
Yeah, as a fraction. C divided by 2. No matter how we write it, it all says the same thing. It's just the last one is most likely the way you would see it. And C is representing the number of carrots. And this one's actually not so bad. The number of carrots shared by 2 people. 2, whatever those are. Guinea pigs. Okay? So I want you to, this phrase isn't actually too bad. Circle the number of carrots divided by 2. We'll put GP next to that. What does GP stand for?
Guinea pigs.
Guinea pigs. So that's actually a pretty good expression for C divided by 2. The number of carrots shared by 2 guinea pigs would be represented by C divided by 2. You have carrots, you're dividing them into 2 equal parts. Okay, and I know we're going quick. I'm just trying to give you as much as I can in 40 minutes. So this one, they want an expression, but then they give us too much information. So on this one, before we do anything else, I want you to mark out where it says, 1 bear left the cave. 1 bear left the cave. We don't care about that. The number of bears in the cave decreased by 1. It gives me an expression in words, and it wants a algebraic expression, a math problem. Bryce, how many bears do we have to start with in the cave? It doesn't say. So what can we use in place of something we do not know in math class? Okay, a B. So this would be B decreased by 1. Ella, what math can we do if it's decreasing by 1? Huh? Minus how many? 1. So an algebraic expression to go with that phrase would be b minus 1. The number of bears decreased by 1. What?
That was pretty simple.
Yeah.
So some of these won't have answers, they'll just be variable. It'll be an expression.
It's an expression, correct.
But I thought an expression needs an equal sign.
No, that's equation.
Equations need an equal sign. So this is just kind of summing up how we can write some of these expressions. So the product of 3 and x. What does product mean in math?
Times.
Multiply. Does that say 3 times x?
No. Yes.
Yes. Why, Bryce? Why does it say 3 times x?
Because it's 3 then x. No, it's an invisible one.
Because the invisible multiplication sign. So let's write that up here. Oops, 3x. Oops. 3x means 3 times x. Now, here's, because you guys don't have a good understanding of this yet, because today's the first day you're seeing it. And you're not going to have a good understanding of it by the end of today. You're just getting the basics of it. But this is not an appropriate way to write x times 3. Okay? We can only do the invisible multiplication sign if the number is in front. So if you put the x in front, that's okay. You just also have to include the multiplication sign. Okay? And again, there's a ton more I can teach you about that, but for now, if you have a number and a variable, just put the number in front. That's the easiest way to remember it. 4 plus j, is there another way I could write that one? J plus 4 is the only other option. X minus 7. Can I do 7 minus x?
No.
Nope, we cannot flip subtraction, so that's the only way there. And let's look at the words here. X minus 7 says x decreased by 7. So if you knew x, you would decrease it by 7, x minus 7. How is the next one different? 2 less than b. 2 less than b. Jude?
Yeah, honestly,
Less than, not like subtract.
Yeah, it's less than, it's not subtract, which what does that do to our expression? Our algebraic expression. Look at what it tells us it is.
Reverse the order.
Bryce?
Just flip the into.
Why? You're not just flipping it, you have to know.
Because 2 is less than b.
Because it's saying 2 is less than, or sorry, not 2 is less. It says 2 less than b. So it's whatever b is minus 2. You're taking 2 away from whatever b happens to be. Jack?
What does it mean when it says reverse the order of the
It's because these words are the ones that people typically would do 2 minus b. Because they see less than, so they go in order, 2 minus b. But if you see less than, that means you have to reverse the order. Because it's saying 2 less than a number we don't know. What about the next one? Is that an expression? N divided by 3 is 7.
No, it's not.
Sophia, is that an expression?
No,
Why not?
because it has an equal sign.
Has an equal sign. What word in a sentence tells us there's going to be an equal sign? Naomi? Is. So if you see the word is, you know that it is an equation, not an equal sign, or not an expression. We can solve equations. Okay, I'm going to show this one a way that you would probably see it if it were on a test of some sort. It would look like that. Okay, I just changed the format of it slightly, but that's just saying what number divided by 3 equals 7. Ethan, what number, when we divide it by 3, do we get 7? 21. So this would just be n equals. So that is a problem we can solve because it is an equation. Why couldn't we solve the other ones?
Because they're not equations.
They're expressions. Yeah, we do not know the value of the variable, and we don't know what they together equal. Last one, twice a number. So 2j, 2 times a number we do not know. Yeah, twice a number, and it's saying the number is j. I doubt you'll see any like that. It's just giving you different wording. Okay, the next slide gives us a ton of information. As we're going through it, we're going to apply it to a big expression. So I want you to copy down this expression. Okay, let's do 5y plus 9 minus 3y plus 4x plus, nope, minus. It's a long one. So that is an expression. Why is it an expression? There's no equal sign. How many terms? You don't know what these words mean yet. If I said how many terms are in that expression, what do you think the answer is? Haley? Why do you think 5?
There's 5 addition and subtraction symbols.
Okay, good guess. There are 5 addition and subtraction symbols, so there are 6 terms. How can we get 6 terms? Dane?
There's 6 different numbers.
There's 6 different, we'll call them numbers, okay? But you look at the stuff besides the plus and minus. So 1, 2, 3, 4, 5, 6. Okay, so there are 6 terms. Let's just make a note of that out to the side. So this has 6 terms. So now we're going to go through some of the bullet points at the top. The first one is a vocab word, a constant. A constant is a number without a variable. So just a regular old number. Looking at that expression, who sees one constant? Sophie, what's one of the constants? 9. And when I circle 9, I'm going to circle it with the sign in front of it. That sign in front of it kind of stays with it. So I want you guys to circle that right there. And I'm going to circle the word constant so that we know we're circling constants. Who sees another constant? Jack? Be careful.
The minus.
Yeah, -3, or we could call it -3. Okay, or -3 is the better way to look at it in 6th grade. Are there any other constants? Numbers without variables. Sadie? That's a variable. Yeah, so there's no other constants because a constant is a number that does not have a variable with it. Okay, so those are our only 2 constants in this problem. A variable is a letter that represents an unknown number. Okay, so there's only one variable by itself up here, but anything with a variable is considered a variable term. So how many variable terms are up here? Jalen, how many variable terms do you think there are?
2.
There's more than 2, Livy. 4. Okay, there's 2 constant terms, 4 terms that have variables in, which is our total of 6. So like terms, again, lots of vocab here, are terms that have the same variable raised to the same power. You can only combine terms if they are like terms. Use circles or underlining to help you locate like terms. The sign directly in front of each term is the sign that goes with them. We can simplify this by combining terms that are like terms. And again, remember we go alphabetical order and then our constants at the back. So what variables do we see? Max, what variables do you see? Y and what other variable? X. Which one comes first in the alphabet? Nolan, X or Y?
X.
X. So we're going to go through and locate all of our X terms, the sign in front of it goes with it. So here's one right here. So I'm going to box this in to show that x. That's a positive 4. What's our other x term? Do we see another x? Bryce? At the end. So I'm going to box in this minus x. More invisible math. What's missing from that x? A number. If you have a variable ever all by itself, it's an invisible number. How many x's are there? 1. There's only one of them. So I want you to dot in. That's how I do my invisible ones, just so I know I need to put it there, but it's not really there. Or I can't see it, but it is really there. Now, we can only combine terms that have the same variable. So right here, we have 4x, and it's a positive. So 4x minus 1. What is 4 minus 1? 3. So 4x minus 1x is 3x. What's another set of like terms? Nolan?
Y.
Okay, we have the y terms, and I'm just going to underline them. We have 5y minus 3y. What do you think 5y minus 3y is, Livy? 2y. So here's what a lot of people put. We're missing something. Haley was kind of on the right track at the beginning. What goes between terms? A plus or minus. Our answer helps us determine if it's a plus sign or a minus sign. Is 5 minus 3 positive 2 or negative 2?
Positive.
Positive 2. So we put a plus sign. Almost always in 6th grade that's going to be positive. But so 5 minus 3 is positive 2. So we put a plus sign. Do we have any other terms that we have not accounted for yet? Jack? So not just the negative 3. So we've taken care of the x's and the y's. Yeah, so now we have 9 minus 3. Sophia, what is 9 minus 3? 6. So we would just put plus 6. This is what you guys would call our answer. Technically, it's not an answer. That's just a simplified expression. How many terms are in that expression? How many terms are there? Nolan?
3.
3. So we simplified 6 terms to 3 terms. Why can't I, what you guys call, give an answer? Jack?
Because you don't have a number for any variable.
Yeah, but if they said x equals 2 and y equals 3, could I then give a 1 number answer? Yeah, I could substitute in the numbers, and we're going to practice that later on in the week. Okay? So that's simplified. And that's what you guys don't like, because you like an answer of like 7.
Yeah.
3x plus 2y plus 6 is your answer, quote unquote. Okay, let's practice some of these. Your guys' is really, really tiny. You will probably have to rewrite these out in your open white space. So out in the white space, I want you to copy down problems 1 through 5 out in the white space. Leave just a little bit of a gap. I'll give you a second to copy those. So you're copying down 1 through 5 out in all that white space. While you're doing that, I'm going to pass out this other paper. Okay, number 1. Again, the previous slide told us to underline, circle, do something to kind of identify our like terms. So when we look, I like to do my work in order of how I put it in my answer. How do I decide what order to go in my answer? Again, I keep using the word answer because that's what you guys think, but it's a simplified version. Nolan, what do we think about?
Alphabetical.
Alphabetical order. So I have x's and what do we call those without x's? Constants. We have x's and we have constants. Which ones do we need to figure out first? No. Constants always go last. So what does it have to be? x's, let's go through and underline our x terms, our variable terms. So we have 2x plus 3x. Nate, what is 2x plus 3x? 5x. Okay, then I just do different types of lines. So I'm going to double underline the constants. We have positive 7 minus 2. What is 7 minus 2, Jude? 5, but then I have another one. So we have 5 plus 3. What's 5 plus 3? 8. Common wrong answer. Carter, what am I missing? Livy, what are we missing?
The sign before the 1 number.
Okay, what sign does it need to be?
Wait, no, what numbers did you all say?
So we've taken care of all of them. That's because I underlined them as I go to make sure I didn't miss anything. So we took 7 minus 2 plus 3. What are we missing? Reese? Ethan, what are we missing? Bryce, what are we missing?
Equal sign?
No, we don't have equal signs because these are expressions, not equations. Naomi.
So, like, sign tells us what we need to do.
Okay, what sign is that? Livy.
Plus?
A plus. Why is it a plus sign? And again, we haven't gotten into a ton of integers. So right now, plus is the only ones that make sense to you.
They're positive.
Because it's a positive 8. 7 minus 2 plus 3 is a positive 8. Okay, let's go on to number 2. So that's our, this is simplified. How many terms were in the original problem? How many terms? Sadie? There were 5 terms, and I simplified it down to 2 terms. Jude, do you have a question?
If you didn't put the plus sign in front of the 8, would it be wrong?
Correct. It is incorrect if you don't have the plus sign. Because looking at it incorrectly, 5x8, again, it's not the proper way, but it could be like 5 times x times 8. Number 2. Who can give me one set of like terms? Addie, can you give me a set of like terms in number 2? 3x and 4x. Ella, what is 3x plus 4x? 7x. Nate, give me another set of like terms. And? Livy? 9. And he said minus 5 first. So I'm going to look at it like that just to teach you a little bit about integers. Negative 5 plus 9. Let's think about this money-wise. If Cooper owed me $5, he's at negative 5. Do you guys agree?
Yes.
Okay, let's say his mom paid him $9 for feeding the cat. Does he have $9? No. Why not? He has to pay me back first. So Cooper, how much money do you have? 4. He has $4. So negative 5 plus 9 is positive 4. He still has $4. He paid me back his debt. He now has positive $4. If we look at it the other way, positive 9 minus 5. What's 9 minus 5? 4. So regardless of how you look at it, you would get 4. You guys just don't understand negative 5 plus 9 yet. But this is still positive 4 no matter how you look at it. Common wrong answer, 11x. How did they get 11x? Sophie? They added. Why can't I add 7x plus 4? Nolan?
It's not like a linked variable.
They're not like terms.
Yeah.
Linked variable, whatever that is. Yeah. They're not like terms. Next one. Who thinks they know? 5x minus x. What do I have to know, Livy, to be able to solve this or simplify it? I have an answer.
Would you take the x away then?
Nope.
No, it's
It's not already simplified. Jude, what do you have to know?
you would put the 1 in front of
There's an invisible 1. So, Livy, now what's 5x minus 1x? 4x. Because this is really 5 times whatever x is minus 1 times whatever x is. So we would, no matter what the value of x is, our end result would be 4 times whatever that x value was. Number 4, 5y plus 7y. Dane, what's 5y plus 7y? 12y. Did I have you guys copy down number 5?
Oh, yes.
Okay. I'm going to scroll up so we can see this one. How many terms are there in that expression, Max?
3.
No. How many terms are there, Bryce? 6. Okay, we have to simplify it by combining the ones that are similar or alike. Carter, will we start with the y's or the constants? Who can answer that question? Will we start with the y's or the constants? Haley? Why will we start with the y's? Because we do alphabetical order of the variables first and always put the constants at the back, which means if there's only one variable, that's what comes first. So we're going to find all of our y's. So we have 6y minus 2y. Sophia, what is 6y minus 2y? 4y minus 2 more y's. 2y, good job. So we're left with 2y. Now we have to work with our constants. Naomi, what is 7 plus 2?
9.
Plus 5.
14.
So we have 2y plus 14 is that simplified version. Yes?
Oh, yeah, never mind.
How many terms does our simplified expression have, Bryce? 2. Okay, look at the other piece of paper I just handed out. These expressions are a little bit, they make a little more sense than those carrots and muffin ones. Write an algebraic expression to abbreviate each sentence, which means turn it into an algebraic expression. Jelly beans shared by 4 people. We don't know how many jelly beans there are. Dane, what could I write that as? J over 4. Good job. What is that math problem? If I see J over 4, what math problem is that? Division. Yeah, division. Jelly beans, the number of jelly beans divided by 4. 5 pumpkins sold at the pumpkin patch. So 5 pumpkins were sold at the pumpkin patch. Livy? What do we not know? How many pumpkins? So what can we use in place of pumpkins that we don't know? What variable do you want to use? Okay, P for pumpkins. And if 5 were picked, I can have 5 minus P or P minus 5. Which one would it be? P minus 5, because its number of pumpkins decreased by 5. Because 5 pumpkins were sold. Jack?
Why does it say sold divided by 50?
It says sold slash picked. They tried to give us different scenarios. Because they could be sold, they could be picked, or it's saying they could have even rolled away. Which I don't think many pumpkins just get up and roll away, but. Okay? Shh. You collected 200 more coins. Stella, can you give me a numeric or a variable expression for that? You collected 200 more coins.
C plus 200.
Good job. See, because the number of coins that we do not know, but we know it increased by 200. $12 per ticket. Chase, how do you think I could show that one? What do we not know? We don't know how many tickets, but if I know it's $12 per ticket, what math problem could I write? That'd be 12 divided by the number of tickets. This one's kind of tricky, but this is probably the most common that starts popping up. No? Nolan?
12T.
12T. 12T or 12 times. If you knew how many tickets you were buying, could you figure out a price for those tickets?
Yes.
Okay. Now, my timer just went off. We're not done just yet. Scroll to the bottom right slide, this one. Okay? Or sorry, you don't scroll, you just look. On here, we're going to do the first one together. A number increased by 4. Jude, what would that look like? Not just plus 4. A number that we do not know increased by 4.
B.
Okay, he wants to use B. B plus 4. I would steer away from B's. Why do you think I would stay away from B's?
Because they look like sixes.
They look like 6s, depending on your writing. Homework. This slide, so all of these little pentagons, when you come in tomorrow, should have an expression under them. Stop. Okay? So this is homework. All of those pentagons should have an expression under them. Flip it to the back. On this one, I just want you to do the left column. So don't mark off the other ones because we might get to them tomorrow. But yeah, just do these 5. 1, 2, 3, 4, 5. Okay, does that make sense?
Yes, that does.
Okay, you guys can go ahead and go. I will see you tomorrow.